Question number 30. The orbital radius of Earth around the Sun. Okay, let us draw the diagram. This is my Sun and this is the Earth. Okay, orbital radius of the Earth around the Sun is 1.5 times that of the Venus. Who is nearby now? Okay, is it the Earth or Venus? It's 1.5 times that of Venus. That means Venus is somewhere over here. Venus is somewhere over here. This is your R, and Earth is somewhere farther away from here. Earth is somewhere farther away. Let me write Earth here. Okay, Earth is somewhere over here. 1.5 times R. Okay, so then what is the intensity of solar radiation on the orbital radius of Venus? What is the intensity on Venus? We already know Earth has a amount of intensity of radiation which the sun radiation emits on Earth is nothing but equal to solar constant. You have learned this, and this value, accurate value, is going to be 1360 watt per square meter. That's why you see there are some numbers given here. You need to know about this, right? 1360 watt per meter square is nothing but your solar constant. Some books also give it as 1380, or crudely you can also remember this as 1400. Anyway, we'll take up this value here, right? Now, what is the intensity of solar radiation? We want to find out. Now, how do you find the intensity? Intensity formula is given by intensity is equal to power by area, right? So, if this is the area over here, if this is the area over here, what is the area of the Venus and what is the area of the Earth? So, this can be written as P divided by 4 pi r square. What is r square over here? The surface area of this, right? So, which is surface area? The surface area of the orbital that I am talking about. Okay, orbital that we are talking about over here, where r is the radius or distance of the orbit from the sun. Okay, so what I will do is I will write I Earth is equal to P divided by power emitted by the sun divided by 4 pi into r square, r Earth square, and I Venus is equal to P divided by 4 pi into r Venus square. Okay, now what do I need? I want the intensity at the Venus, right? I already know about the Earth. So I will write I Venus by I Earth is equal to P by 4 pi r V square multiplied by 4 pi r E square divided by P. So P and P cancels, 4 pi and 4 pi cancels over here, right? So, and thus what am I left out? I am left out with RE divided by RV the whole square. RE by RV the whole square. Now what is that we have got? We already got, this is your RV and this is your 1.5 times RV, right? So this is what we have. So what I will do is I will just substitute this as RE. I will just substitute it like this, and this is your RE, right? This is your RV. So I will just substitute this as 1.5 times RV divided by RV the whole square. So RV cancels, you get 1.5 square, which is 2.25, right? So IV by IE is equal to 2.25, but this does not answer us anything here. Okay, let me write down. I don't have space on the downside, so I will write it down here. I'll continue here. So you have IV by IE is equal to 2.25. So IV is equal to 2.25 times IE, right? Because it's nearby, it should be larger, which will be 2.25 times. What is IE? IE I already told you, which is nothing but your solar constant, right? Which will be 1360. When I do this, how much do I get? I get the answer as 3060 watt per meter square. Okay, or I can now write this as nearly 3 kilowatt per square meter. Which is the right option? Option D is the right option. Okay, so thus we have found out the intensity of the sun rays falling on Venus. Okay.